So it's Science in the City at Trent University Forensic Department, Crime Scene House. What do you do here?
We set up mock scenes, and basically we can investigate what's been going on.
Well, this place is a mess. There's blood on the walls and stains everywhere.
It's not a mess to us, it's evidence.
Which I guess is good, because today we're going to look at fingerprints. Science of fingerprints. It looks like what you've done there is you've used sort of standard dusting or powdering of fingerprints.
We use black powder to develop the fingerprints on the wall, and what happens is it adheres to the amino acids in the fingerprints.
Let's look at the science of fingerprinting when you might not even be able to see the fingerprints, might not even know where they are. We can use super glue to capture fingerprints. At least that's the theory. Now we've got to figure out the science. Let's try a little test here to see if we can understand a little bit about how cyanoacrylate works. I've got a glass bottle here and a plastic lid, and I like to stick the two of them together. We've got a nice dry surface here, some dry plastic and dry glass, and I'm going to put a few drops of glue on the bottom of this. It doesn't stick perfectly. Okay, add some moisture. And it sticks right away. So cyanoacrylate, when it comes in contact with water and other materials, that's what triggers the chemical reaction that causes it to harden and bond. So, what do you find in fingerprints?
Well, Ellen, you'd find sweat in your fingerprints.
Sweat, and what else?
Amino acids.
Oils?
Oils, yeah.
Things like that. So your fingerprints leave behind a bunch of grime that might react with the superglue. We just have to get the superglue in contact with the fingerprints. And that's what this chamber is for. Let's find some fingerprints using superglue. So we need something with fingerprints. So Nicole, why don't you cover that with some fingerprints?
There you go.
Okay, now we plant this at the scene of a crime. And let's use this to see if we can capture some fingerprints, okay? Remember, water is important. So we're going to add a little bit of warm water. Just to help increase the vapor content. We've got a little foil bowl here that's going to sit on top of an incandescent bulb. And that incandescent bulb is going to get very, very hot. And it's going to heat the superglue to its boiling point. It's going to vaporize it. Here's our cyanoacrylate glue. Let's throw 3 or 4 or 5 drops on there. Lots of stuff. Okay. Now we need to make the chamber airtight. All we need to do now is add some heat. So what do you guys think is happening in the tank?
I think the heat from the light is heating up the glue and creating vapors and fumes, so they will be able to attach onto the oils and fats left by the fingerprint.
Exactly. We're vaporizing the glue, the vapor's getting into the air, and glue molecules will eventually come in contact with the water and oils in the fingerprint, adhere and bond, and give us a nice fingerprint.
Damn.
You definitely can see them.
Yeah, I see a white one.
So you guys ready to look at the results?
Yeah.
Okay, it's been in there for about 20 minutes, which is about the shortest you'd really want to do this test, but it's time to open it up. Aaliyah, can you come and help me sort of peel some of this plastic back? Out it comes. And look, oh, there's a...
That's really good.
All of a sudden, those invisible prints have become visible. So we've got Nicole's fingerprints all over this thing. They're made white because the cyanoacrylate vapors adhere to the materials left behind by the ridges of your fingerprints. And that's a nice little chemical reaction that goes on there to give us a visible fingerprint and collect evidence to find the suspects.
And that's what forensic science is all about.